Okay, we're going to continue our discussion moving into t-test for two samples, but just as a refresher, this information should look fairly familiar. This is the formula that you would need in order to conduct a t-test for one sample. And I want to point a couple of things out to you about this, very important things to keep in mind. T-test for one sample. There's only one opportunity for sampling error or for error period to come into the mix. One sample mean minus the population mean that is a given, right? So the difference between a sample mean and a population mean, which then gets standardized by the standard error for the sample, S sub x bar. This symbol, S sub x bar, is, as you know, I'm sure, from previous YouTube lectures and all the work you've been doing with the standard error, this symbol, this is all one symbol, and the formula for that, S sub x bar, is the sample standard deviation, which I would hope is a familiar concept by now, divided by the square root of n, where n is the total number of cases. Likewise, you may recall that the degrees of freedom when conducting a t-test for one sample is relatively simple as well. N minus 1, the number of cases in our sample minus 1. Okay. In a t-test for two samples, the formula is a little bit different. We are still calculating a data-generated t-value, okay? Units of standard error. Units of standard error. That's what t represents, units of standard error. We're still calculating a data-generated t-value, a t-value that will come from our data. However, we are going to begin by taking the difference of the mean for our first sample and subtracting the mean for our second sample. X with a bar sub 1 is the mean for your first group of scores, your first sample. X with a bar sub 2 is the mean for your second sample. Okay? So in the numerator, we still have the difference between two things, and in fact, we have the difference between two means. However, the two means come from two samples. Therefore, there are two opportunities for error to come into the mix from sample 1 and sample 2. Two opportunities for error. Now, we're still going to calculate that difference, mean 1 minus mean 2, whatever that might be, whatever that difference might be, and we are going to standardize that difference by a measure of standard error. Now, this symbol, it looks pretty complicated, but it's really not. I want to point out very clearly on this video that this denominator, even though you see a lot of parts, S sub x bar 1 minus sub x bar 2, that is just one symbol. So please commit that to memory and keep that in mind. S sub x bar 1 minus sub x bar 2, this is one symbol. And what that symbol represents, or what its technical name is, the standard error of the difference. The standard error of the difference. What that symbol is doing, the most important thing you need to keep in mind about this symbol, the denominator of the data-generated t formula for a t-test for two samples, the thing you need to keep in mind, the most important thing to keep in mind about this symbol is that it represents the standard error for the two samples that you're working with. That's it. Okay? So data-generated t for a t-test for two samples equals mean 1 minus mean 2 divided by a measure of standard error, specifically the measure of standard error for the two samples that you're working with. Now, another very important difference that you may already be cognizant of, the degrees of freedom are different. The degrees of freedom are different for a t-test for two samples. The degrees of freedom are calculated by taking n sub 1, that's the sample size, that's the number of cases in your first sample, plus n sub 2, that's the number of cases in your second sample, minus 2. So keep that in mind as well. N sub 1 plus n sub 2 minus 2. in future clips, when we're going through examples, I might just simply say n1 plus n2 minus 2, which I might not say sub. But get a hold of a copy of this, keep it handy. T-test for two samples. Data generated T is found by taking mean 1 minus mean 2 divided by the measure of standard error for the two samples. Its technical name is the standard error of the difference. But again, what that means is that you're simply taking two measures of standard error into account. The other difference you need to keep in mind is the calculation of the degrees of freedom. DF for a t-test for two samples equals n sub 1 plus n sub 2 minus 2. That's it. I will return by discussing a little bit more about this value here and how to calculate it.